Welcome to AI Frontiers, where we explore the cutting edge of artificial intelligence research. Today we're diving into groundbreaking discoveries from computer science artificial intelligence research published on November 1, 2025. We'll analyze 14 revolutionary papers that are reshaping our understanding of AI systems, from hidden computational bottlenecks to safety breakthroughs. This is your guide to tomorrow's intelligent systems. Picture this. Right now, as you're listening, an AI agent somewhere in the world is orchestrating a symphony of digital tools to solve complex problems. It's calling APIs, analyzing data, making decisions, and coordinating with other AI systems. But here's the shocking discovery that researchers just uncovered. The bottleneck isn't the powerful GPU doing the heavy thinking. It's the humble CPU, quietly working in the background, that's consuming up to 90% of the total processing time. This revelation is completely overturning industry assumptions and changing how we think about building AI infrastructure. Today we're embarking on a journey through 14 revolutionary papers that emerged from the computer science artificial intelligence domain. These aren't just academic exercises, they're glimpses into a future where AI systems think more like humans, reason across multiple senses, and adapt to our diverse world with unprecedented sophistication. We'll uncover hidden computational bottlenecks, explore AI systems that can genuinely expand their own capabilities, and discover how researchers are solving the puzzle of making AI both powerful and safe. To understand where we're heading, let's first map the territory we're exploring. Computer science artificial intelligence, or CSDI, as researchers call it, is like a vast digital ecosystem where minds are being born from mathematics and code. Think of it as a bustling metropolis where every building represents a different approach to creating intelligence. In one district, you have the towering skyscrapers of large language models, processing human language with remarkable fluency. In another, you'll find the interconnected networks of multi-agent systems, where AI entities collaborate like a well-orchestrated jazz ensemble. There are the precision-engineered districts of reasoning systems, the vibrant multimedia neighborhoods where AI learns to see and understand images alongside texts, and the carefully guarded safety sectors where researchers work tirelessly to ensure these digital minds remain beneficial and aligned with human values. What makes this field particularly fascinating is its explosive growth and diversification. Unlike traditional computer science domains that might focus on optimizing existing solutions, AI research is simultaneously pushing the boundaries of what's possible, while grappling with entirely new categories of challenges. As we dive deeper into this research, 6 major themes emerge, like rivers flowing through this vast landscape of artificial intelligence. The first major current is what researchers call agentic AI and multi-agent systems. Imagine the difference between a sophisticated calculator and a human assistant. The calculator, no matter how powerful, waits for you to input problems and then provides answers. But a human assistant anticipates needs, coordinates multiple tasks, makes decisions independently, and adapts strategies based on changing circumstances. This is the leap AI is making right now. We're witnessing the emergence of AI agents that don't just process information. They actively orchestrate solutions. These systems can manage multiple tools simultaneously, coordinate with other AI agents, and make autonomous decisions in complex environments. One fascinating example from our research shows AI systems automatically diagnosing and fixing telecommunications network problems, coordinating between different diagnostic tools and databases, like a team of expert technicians working in perfect harmony. Raj and colleagues revealed that these sophisticated systems face hidden CPU bottlenecks that consume the majority of processing time, fundamentally challenging our assumptions about AI infrastructure requirements. The second theme focuses on reasoning and problem-solving enhancement, and this is where things get really exciting. Traditional AI systems excel at pattern recognition. They can identify cats in photos or translate languages with impressive accuracy. But reasoning, the ability to think through multi-step problems, navigate complex logical relationships, and solve novel challenges, has remained elusive. The research we're examining today shows AI systems learning to navigate through complex spatial environments, plan solutions that involve numeric constraints, and even avoid the trap of overthinking problems. It's like teaching a brilliant but inexperienced student not just what to think, but how to think more effectively. One breakthrough study demonstrated vision language models achieving 50% accuracy on spatial reasoning, tasks they previously failed completely, proving that AI capability boundaries can be genuinely expanded through targeted training approaches. These improvements weren't just memorization. The enhanced reasoning capabilities generalized to real-world navigation tasks with significant performance improvements. Safety and alignment emerges as our third critical theme, and this might be the most important conversation happening in AI research today. As these systems become more powerful and autonomous, ensuring they behave safely and align with human values becomes paramount. Think of it like raising an exceptionally gifted child. You want to nurture their capabilities while ensuring they develop strong moral reasoning and cultural sensitivity. The papers we're exploring reveal innovative approaches to this challenge, from AI systems that can adapt their ethical reasoning to different cultural contexts, to new methods for testing AI reliability in high-stakes domains like legal reasoning. Rather than encoding rigid safety rules that apply universally, researchers are developing frameworks that enable AI systems to engage in deliberative ethical reasoning, considering regional specificities, cultural nuances, and contextual factors when making decisions about appropriate behavior. This represents a significant advance toward AI systems that can operate responsibly in our diverse global context, rather than imposing a single set of values universally. Now, let's explore the key findings that are reshaping our understanding of AI systems and their potential. These discoveries read like detective stories, where researchers uncover hidden truths that challenge our assumptions and open new possibilities. Our first major discovery centers on those hidden computational bottlenecks. Researchers conducting detailed analysis of agentic AI systems made a startling discovery that's causing the entire industry to reconsider their infrastructure strategies. While everyone has been focused on building bigger and faster GPUs to handle AI workloads, the real bottleneck was hiding in plain sight. When AI agents orchestrate multiple tools, make decisions, and coordinate complex workflows, they spend most of their time on CPU-intensive tasks like parsing responses, coordinating between components, and managing memory. In some cases, these CPU operations consume over 90% of the total processing time, while the expensive GPUs sit relatively idle. The second breakthrough challenges a fundamental assumption about AI capabilities. Researchers took vision language models that achieved 0% accuracy on spatial reasoning tasks, and through targeted reinforcement learning achieved over 50% accuracy, with improvements generalizing to real-world navigation tasks. This proves AI capabilities aren't fixed ceilings, they're elastic boundaries that can be stretched with the right training approaches. Among all the fascinating research we're exploring today, one paper stands out as particularly groundbreaking in its implications for the future of AI systems. A CPU-centric perspective on Agentic AI by Ritik Raj and his colleagues represents the kind of paradigm-shifting research that forces an entire field to reconsider its fundamental assumptions. The story begins with a puzzle that was hiding in plain sight. As AI systems evolved from simple input-output models to sophisticated agents capable of using tools and making complex decisions, researchers noticed something strange. Despite massive investments in GPU infrastructure, these agentic AI systems weren't performing as well as expected. The bottleneck seemed to be somewhere else entirely, but where? Raj and his team decided to investigate this mystery with the thoroughness of forensic detectives. They systematically profiled 5 representative agentic AI frameworks, including popular systems like Haystack RAG, Toolformer, and Chemcro. But instead of just measuring overall performance, they dove deep into the computational anatomy of these systems, tracking exactly where time and energy were being consumed at every step of the process. What they discovered was revolutionary. While everyone had been focused on the dramatic, high-profile work of language model inference happening on GPUs, the real computational heavy lifting was occurring in the background on CPUs. These systems spend enormous amounts of time orchestrating external tools, parsing complex responses, making decisions about next steps, and coordinating between different components. In some configurations, these CPU-intensive operations consumed up to 90.6% of total latency, while the expensive GPUs that everyone assumed were the bottleneck were actually waiting around for the CPUs to finish their work. Think of it like discovering that in a Formula One race, the cars aren't limited by their engines, but by the time spent in pit stops. The researchers discovered several specific CPU-related bottlenecks, creating these performance issues. Coherence problems arose when multiple processor cores needed to coordinate their work. Synchronization overhead occurred when different components had to wait for each other to complete tasks. Oversubscription issues emerged when too many processes competed for limited CPU resources. Each of these problems compounded the others, creating a cascade of inefficiencies. The energy consumption analysis revealed that CPU dynamic energy consumption could account for up to 44% of total energy usage in large-scale deployments. Armed with these insights, Raj's team developed two innovative optimization strategies. Their CPU and GPU-aware micro-batching approach dynamically adjusts processing batch sizes based on both CPU and GPU utilization patterns, ensuring that neither component becomes a bottleneck. Their mixed agentic workload scheduling system optimizes the execution order of different types of tasks to minimize coordination overhead and resource conflicts. The results were impressive, achieving up to 2.1 times latency improvements compared to standard approaches. But the real significance goes far beyond these immediate performance gains. This research suggests that the entire AI industry needs to fundamentally reconsider its infrastructure investment strategies. The practical implications are already being felt across the industry. Cloud computing providers are reconsidering their hardware configurations, balancing CPU and GPU capabilities more carefully. Organizations deploying agentic AI systems are redesigning their architectures based on these findings. Chip manufacturers are exploring new processor designs, optimized for agentic AI workloads. The work also suggests that as AI systems continue to evolve, we'll need to continuously reevaluate our assumptions about computational bottlenecks and optimization strategies. As we gaze into the crystal ball of AI research, the papers we've explored today paint a picture of a field that's not just advancing but transforming in fundamental ways. Think of AI research like a river delta, where a single stream of early artificial intelligence has now branched into dozens of specialized channels, each flowing toward different applications and capabilities, but all ultimately contributing to a vast ocean of artificial intelligence that will reshape human civilization. The trajectory we're witnessing suggests several exciting developments on the horizon. First, we're moving toward AI systems that are genuinely collaborative partners rather than sophisticated tools. These systems will be able to understand context, anticipate needs, and adapt their behavior based on cultural and individual preferences. The integration of multimodal capabilities will likely lead to AI systems that perceive and understand the world more like humans do, combining visual, textual, and contextual information seamlessly. The efficiency breakthroughs we've discussed suggest that sophisticated AI capabilities will become more democratically accessible. As researchers develop more parameter-efficient methods and optimize computational architectures, we can expect powerful AI systems to run on increasingly modest hardware. Perhaps most importantly, the advances in safety and alignment research suggest we're developing the tools needed to ensure that increasingly powerful AI systems remain beneficial and controllable. The transformation ahead represents a fundamental shift from AI as sophisticated tools to AI as genuine partners in human endeavors. The 6 major themes we've explored: agentic AI systems, reasoning enhancement, safety and alignment, efficiency optimization, multimodal understanding, and domain-specific applications, are converging to create AI systems that can think, reason, and collaborate in ways that were purely science fiction just years ago. The hidden bottlenecks revealed in our research are opening new optimization opportunities that will make these advanced capabilities more accessible and efficient. Safety and efficiency advances are enabling deployment of increasingly sophisticated systems while maintaining reliability and cultural sensitivity. The maturation of ethical reasoning capabilities suggests we're approaching AI systems that can navigate complex moral landscapes while adapting to diverse cultural contexts. Most exciting of all, the future of human-AI collaboration is emerging, where AI systems don't just follow commands, but engage in genuine dialogue about goals, trade-offs, and creative solutions. These systems will be able to continuously learn and expand their capabilities, becoming increasingly valuable partners in scientific research, creative endeavors, and complex problem-solving across every domain of human activity. Before we conclude, let's discuss how this research synthesis was created to ensure transparency in our process. This comprehensive analysis utilized advanced AI tools including GPT and Anthropic Claude Sonnet 4, released on May 14, 2025, for processing and synthesizing the complex research papers. Text-to-speech synthesis was powered by DeepGram technology to create the natural-sounding narration you're hearing. Image generation was accomplished using OpenAI's latest systems to create visual representations of the research concepts. Importantly, all synthesized content underwent human expert review to ensure accuracy and proper interpretation of the technical material. We want to acknowledge that despite our rigorous process, some oversights may exist in this synthesis. We encourage listeners to refer to the original research papers, available through the archive preprint server, for complete technical details and to verify any specific claims that are critical to your work. This transparency is essential as AI-assisted research synthesis becomes more common. Understanding the tools and processes behind content creation helps maintain scientific integrity while leveraging the power of AI to make complex research more accessible. Thank you for joining us on this journey through the cutting edge of artificial intelligence research. We've explored revolutionary discoveries that are reshaping how we understand AI systems, from the hidden CPU bottlenecks that are transforming infrastructure strategies to the breakthrough methods for expanding AI reasoning capabilities. We've seen how researchers are solving the critical challenges of safety and cultural alignment while making sophisticated AI capabilities more efficient and accessible. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archivepreprinserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archivepreprinserver.org.